Hi everyone. Today's lesson is just really moving on from what we did in the last lesson. So the last lesson we looked at electronic structure again. We looked at why the elements in group 8 or group 0 are so unreactive. And again, we linked the group number to the number of electrons in the outer shell of an element. Now, this quote came up in the last lesson and it applies again today. So protons give an element its identity and electrons give it its personality. And really what we're looking at there is that it's the electrons that determine how reactive an element is or how it would behave in a particular reaction. And we're going to use that knowledge today and start to build up an idea of how different groups in the periodic table actually behave. Now, in today's lesson, we're going to focus on group 1, and then we're going to move on from that then in our following lessons. But today we're going to look at a group overview, and then we're going to look at group 1 in particular. So let's move on to the next slide. Now, we already know that the group number in the periodic table relates to the number of outer electrons or valence electrons that an element will have. So we already know that if we look at group 1, or we should know, if we look at any of these elements in group 1, then the number of outer electrons that any of these atoms should have should be 1. So we have 1 electron in group 1. For group 2 then, because it's group 2, they should have 2 electrons in their outer shell. For group 3, 3 electrons. For group 4, 4 electrons in their outer shell. Group 5, 5 electrons. Group 6, 6 electrons. Group 7, 7 electrons. And finally, group 8, or as it's sometimes known, group 0, will have 8 electrons in its outer shell, all apart from helium. Obviously, helium doesn't have enough electrons to fill a second shell to have 8, but it has a full outer shell with 2. The only element that we're worried about that doesn't really fit into the groups is hydrogen. And hydrogen in this periodic table is in the middle of the periodic table purely because it behaves like a group 1 metal, but it's not a metal. So it's in the middle, but you will see in some periodic tables hydrogen will actually be put in group 1 because it's got 1 electron in its outer shell, and because of that it behaves like the group 1 metals. So really what we should take from this wee slide is how many electrons are in the outer shell if you're in a specific group, and that the number of electrons in your outer shell determines how you will behave in a reaction. Turn to page 106 with me and pause while you turn to that if you haven't already. At the top of page 106 there's a sentence and it says this: elements in the same group in the modern periodic table have similar chemical properties. And then in the next sentence, you have to complete it. And hopefully you're getting the idea of today's lesson through me saying it over and over. But this is because they have the same number of electrons in their outer shell. So the whole thing together, elements in the same group in the modern periodic table have similar chemical properties. This is because they have the same number of electrons in their outer shell. And you need to copy that down in the green box there onto the lines at the top of page 106. But I hope this is starting to sink in. The number of electrons in your outer shell determine how you behave. So if you have the same number of electrons in your outer shell, you behave the same. Okay, time to move on to the next slide. Just below where we have written there's a table now, and I've put the table up on this slide. And what you've been given is you've been given the group number, both in normal numbers and in Roman numerals, because you could be given either in a periodic table. And what we have to do is we have to learn the name of these groups, and we have to learn how reactive they are. These are the most important ones: 1, 2, 7, and group 0, or group 8. These are the groups we need to know about in terms of their properties, some of their reactions, and predictions we might make about them. But the first thing we must know is their name. So let's look at group 1. Group 1's name is the alkali metals. So you need to write that in there. Group 1 is otherwise known as the alkali metals. And they are known to be very reactive. So group 1 metals you don't want to play around with because they are very reactive. It makes them very unpredictable and they react very vigorously in a reaction. And so we don't use them an awful lot. It's quite a common exam question. Why do we not use potassium in this reaction? And potassium is a group 1 metal. It's an alkali metal. And your answer would be because it is too reactive, or it would react too vigorously. That's a really common word in chemistry. Now looking at group 2, they're known as the alkaline earth metals. So it's important you don't mix up the names of group 1 and group 2. Group 1 is the alkali metals, group 2 is alkaline earth metals. And they're still reactive. They're not as reactive as group 1, so we just describe them as reactive. Group 7 then is also known as the halogens, a strange name, but they're called the halogens, and they are the most reactive nonmetals. And the reason for this is they have 7 electrons in their outer shell. So think about it. They only need to have 8 to have a full outer shell. So they only need one more. So they don't have to do an awful lot, which makes them very reactive. So they're the halogens and they're described as very reactive. And then finally, group 0 or group 8, both is accepted, remember, are called the noble gases, as we know. And you already know their reactivity. You could fill this in without me. They are non-reactive because they are stable. They don't react at all. They don't need to. They already have a full outer shell. So that's everything for that table, and it's everything for this slide, so we can move on. At the bottom of page 106, you will see this version of the periodic table, and it's just a nice version because it's color-coded and it's labeled. So you can see we've labeled the alkali metals there. We've labeled the alkaline earth metals. You can see the transition metals are the transition block in the middle. Transition because they tend to change about without us planning it. We don't really worry about groups 3, 4, 5, or 6. They're kind of meh in terms of reactivity. And then we look at group 7, the halogens, very reactive, and the noble gases, which aren't reactive at all. So really important that you're able to identify these groups within a periodic table. Now turn to page 107 with me, and I've taken a screenshot of that page and put it onto this slide, as well as group 1 from the periodic table. And you'll see in this specific periodic table I've used hydrogen is included in group 1 because it's got 1 electron in its outer shell. Now looking at this page, the title is Group 1, the alkali metals. So we're focusing on them now. We're just focusing on their properties and their reactivity. And you can see at the top of the metals, we've got lithium. And lithium has been drawn here on the slide. And you can see it's got 3 electrons in total, 2 in the first shell, 1 in the outer shell. And it's got two shells then. Sodium is next. So looking at sodium, we go across the right of the page. We can see there are 2 electrons in the first shell, 8 in the second, and 1 in the third. So it's got the same number of outer electrons as lithium, but it's got 1 more shell. So there's 1 more layer of electrons between the nucleus and the outer electron. Finally, the last metal we're kind of looking at is potassium. Potassium, you can see down here, has got 2 electrons in the first shell, 8 in the second, 8 in the third, and 1 in the outer. So same as before, they all have one electron in their outer shell, but as we go down the group, we add a shell on. So we add more distance between the outer electron and the nucleus, and that will impact how they react. The more distance we add in, there will be a change in reactivity. So we're asked at the very top of this page, is there a pattern in reactivity in group 1? And there is. The pattern is this. The metals become more reactive as you move down group 1. Now I want you to pause here and I want you to write that in before I go further and explain why that happens. Hopefully you've paused and you have written that in. The reason why they become more reactive down group 1 is because of this distance that we have between the nucleus and the outer shell. With lithium, there's a very small distance. So that means that that outer electron is held very tightly by the nucleus. If you look at sodium, there's one more layer in between the nucleus and the outer electron, so it's not held as tightly, which means it can be more easily lost. And if it's more easily lost, that means it's more likely to get involved in a reaction. Potassium, again, there's another layer more than sodium. Again, that outer electron is even more easily lost, which means it's even more easily involved in a reaction. And the more easy, or the easier it is for you to be involved in a reaction, the more reactive you will be. That's the general rules there. Okay? So bigger distance, more reactive. For the alkali metals, it's not the same for everyone, but for the alkali metals it is, because they are losing their outer electron. Now you'll see on this page in the middle, there's a few key things about these metals. So the metals are stored in oil to prevent them from reacting with moisture in the air. So they are so reactive that I couldn't leave them sitting out. They would react, they would go on fire, they would explode. It would be dramatic, it would be fun, but I would have no job to go to because I'd blow up my classroom. The next thing then is the metals have a shiny surface when freshly cut, but tarnish rapidly in air to appear dull. So they have a shiny surface when you first cut into them, but what will happen is they will start to react with the air around them, and it makes them appear dull, a bit like old cutlery. New cutlery is very, very shiny, or even like a new trophy is very shiny, but once it gets older, it starts to tarnish. And then finally, the group 1 metals are very reactive since they only need to lose one outer electron to achieve a stable full outer shell of 8 electrons. So we know that they only need to lose one. The bigger they are, the further down the group they are, the more easily they will lose it, and the more reactive they will be. And then the final question at the bottom of the page: why do the elements in group 1 have similar properties? You could be asked this question for any group. Why do the elements in group 6 have similar properties? Why do the elements in group 3 have similar properties? Your answer will always be the same. Remember, properties are determined by outer electrons. So why do the elements in group 1 have similar properties? Well, the answer is they have the same number of electrons in their outer shell. And if you want to be specific to group 1, you can say they all have one electron in their outer shell. But that's the reason why these groups have similar properties. That's why some people call the groups families. They behave the same. They've got similar traits because they all have the same number of electrons in their outer shell. Now finally, we're on page 108, and this is the last thing we're going to do, working with those two boxes at the top of the page. The one on the left talks about the properties of group 1 metals. So we know why they all have the same properties, because they have the same number of electrons in their outer shell. But now we need to learn what those properties are. So you need to write these in and you need to learn them. So if you look at the properties here, they have a low density. They're less dense than water. So what will happen there is if I react them with water, they should all float on the surface of the water. They're easily cut. They're very soft metals. So that means actually if I had a piece of them, I could squash them within my fingers, or I could cut through them very easily with a knife. And I mean, you wouldn't take a knife to those legs of the tables in the classroom, you'd be there all day, but a knife very quickly will cut through these. They're as soft as butter that you've taken out of the fridge. That's how easy they are to cut. They're shiny when freshly cut. I mean, metals are shiny, so they're shiny until they start to react. And then when they react, they tarnish rapidly in air. They become very dull. They're very reactive, and that's a property, and that's an easy one to learn. And then finally, group 1 compounds are white as solids and colorless when dissolved. So they are white when you react them with something and keep them as a solid, but if you react them and they turn out to be a solution, they will be colorless. So their compounds are white as solids and colorless when dissolved. And the final thing we have to do today is we have to fill in this box, how to store and manage risks of group 1 metals. This is a very common 6-mark question that comes up. So it can be incorporated into short questions or into long questions. So really important that you learn it. When they start to ask you safety precautions in chemistry for a particular experiment or a particular element, you've got to be specific to that. It's not enough to say tie hair back, tuck your tie in, put your stool under your desk. That's generic. That should be done already as good practice. So it's not really considered to be a way to manage risks at GCSE. What you're looking at here is the metals react in air. So we store them in paraffin oil. So no water or no air can react with them. Use tweezers when you're working with them. Don't use your hands. They'll react with the moisture on your hands and they will burn. So we use tweezers. The third thing is we cut or we use small volumes of the metal. If you use too much, like I tend to, because I really like these metals, so I like to use slightly bigger pieces and see how much of an explosion I can get. The problem with that is when you use too big a volume, what can happen is they bounce out of the reaction and they can land on someone. So you want to use a small volume so it isn't too reactive and it isn't a danger to those doing the reaction. The fourth thing then, complete experiments behind a safety screen. So the safety screen is basically, do you remember before we went off there, before Christmas, what I had up on my desk? It's like a clear screen and you put it around the experiment and it stops the likes of the metal bouncing out and hitting somebody or sparks flying out and hurting someone. So a safety screen is very useful. And then the last thing, which is the most generic answer you could give, is wear safety goggles. But you would have to explain why. Obviously, to prevent solution or metal or sparks from getting into your eye. So that's it for today. I want you to make sure you've got all these notes written in from page 106 to 108. You have to learn this off. So you've got to learn, why do elements in the same group have the same properties? What are the properties of group 1 metals? How do you store and manage the risks of group 1 metals? And then you need to know if there's a pattern of reactivity in group 1. Okay, take care, folks. Make sure you get that done. Any problems, send me a message and I'll try and get back to you as soon as possible. Okay, take care. Bye bye.